For number 1, we're asked to evaluate the definite intervals using the area under the curve. So we're finding the area under the curve y equals 3, right? That's our equation, from -2 to 5. So let's look at a graph. So our graph is y equals 3, and we're going from -2 to 5. So we have this rectangle underneath. We're just looking for the area of it. So the base is going to be 7, going from -2 to 5, and the height is 3. So this definite integral is going to be equal to 21. For number 2, let's switch this. Let's change this to 3 minus 3x. It's going to make it a little bit easier for now. All right, here we have a line, just a regular line, slope and y-intercept, so we can graph this. So our y-intercept is positive 3. Slope is -3, so we're going down 3 over 1, down 3 over 1. And we can even kind of backtrack from our y-intercept, go up 3 to the left 1. And now we're trying to find the area under the curve from -1 to 2. So we have 2 triangles, one above the x-axis and one below. The one above the x-axis has a base of 2, it's going from -1 to 1, and the height is 6. We can kind of tell from our graph, right, when we were at 3, we went up 3 over 1. But if you can't tell from a graph, you can always just substitute it into the formula. So if we put -1 into this equation, 3 minus 3 times -1, that would give us 6. Over here, we have a base of 1, height of -3. Again, if we put 2 into this equation, 3 minus 3 times 2 gives us the y value. So -3 is our height. So this one, we have an area 1/2 times 2 times 6. An area of 6. Our other triangle, 1/2 times 1 times -3. So -1.5. Means our definite integral would be 4.5. And our last one here, absolute value, so it's going to be a V shape. Since we're adding 2, that is moving the graph up 2. So our vertex is at 2 on the y-axis. And this one we're trying to find the area under the curve from -3 to 5. So we end up with 2 trapezoids, and we can find the area out. This one has a height of 3. This one has a height of 5. We can tell this base right here is 2, as we move that up 2. Then to find these, we can just use the equation. If we're putting -3 into this equation, we end up getting a base of 5 right here. On this side, if we put 5 into the equation, we end up getting a base of 7. So for our first trapezoid, we have 1/2 times 5 plus 2 times 3. That's 21/2. And our other one, we're going to have 1/2 times 2 plus 7 times 5. So we get 45 halves. If we add those up, we get 66 halves, or 33.